Soalan nombor 1A, evaluate integrate x over 1 plus x square dx. So, kita menggunakan kaedah substitution. Cari dia punya u dulu. U equal to 1 plus x square. Cari du over dx. Differentiate, dapat 2x. And then susun semula, dx equal to du over 2x. And then buat solving. Integrate x over u yang kita dah dapat tadi, darab dengan dx. dx which is equal to du over 2x. Dapat yang sama boleh potong. And then constant bawa keluar 1 over 2, integrate 1 over u. Sebab x kita sudah potong tadi. So, tinggal 1 over u du. Nombor integrate sign equal to 1 over 2. 1 over u jadi ln u. And then 1 over 2 dalam kurungan, gantikan ln u which is 1 plus x square dalam ni. And then tutup kurungan, lower limit is 0 and upper limit is 3. And then substitute the upper limit minus the lower limit equal to 1 over 2 ln 10 over 1. And then eventually you will get the answer 1 over 2 ln 10. B, we use substitution method as well. And then u kita dapat e kuasa x. And then differentiate du over dx sama dengan e kuasa x. Then dx equal to du over e kuasa x. And then equal to du over u. Sebab u sama dengan e kuasa x. Integrate u minus 1 over u plus 1 du over u. When x equal to 1, u equal to e. When x equal to 0, u equal to 1. So, this is the upper limit. This is the lower limit. So, u ni kita darab masuk. So, dapat u minus 1 over u dalam tanda kurung u plus 1 du. So, jawapan akhir dia, since kita dah cari dia punya upper limit and lower limit, so kita just substitutekan and then tulis balik yang ni and then shown. Kita belum habis lagi. Hence, soalan minta find the exact value of this one. So, kita guna partial fraction method. U minus 1 over u plus 1 equal to a over u plus b over u plus 1. Then u minus 1 equal to a darab u tambah 1 tambah b darab dengan u. So, when u equal to negative 1, b equal to 2. When u equal to 0, a equal to negative 1. So, kita just substitute daripada equation ni. Kita dapat nilai b and a. Kita tulis balik equation ni yang kita dapat daripada yang kita dah show ni. Since kita dah dapat nilai b and nilai a, kita salin balik equation ni yang kita dapat daripada yang kita dah integrate tadi. Equal to, so substitute nilai a and b yang kita dapat daripada ni. So, kita solvekan. Negative 1 over u jadi negative ln u plus u over 2 plus 1 jadi 2 ln u plus 1. And then close the bracket, upper limit and then lower limit. And then substitute all upper limit minus the lower limit. And then nanti eventually akan dapat jawapan ln e plus 1 square over 4e.
Hello everyone, now we're going to do question number 2. It says the region R is bounded by the curve y equals to cert 2 sine cert x and the line x equals to pi square and the x-axis. Show that the area of the region R is equal to 2 cert 2 pi unit squared. So now when we get an equation of the curve and also an equation of the line, we will try to draw it out. So here I've drawn it out, where this is the equation y equals to cert 2 sine cert x, and this is the line x equals to pi square. From here we can see that the region R is located here since it says that it is bounded by the x-axis. Now from here we can get the formula of the area, whereas area is equals to cert 2 sine cert x dx, where the points are 0 to pi squared, where you can see from here. Now when we will get this type of equation, we will try our best to let sine cert x be alone with the integrate. So we will bring cert 2 to the left, where you will get something like this. Now when you see this equation here, sine cert x, we can't use normal differentiate method, so we will use substitution method, where u is equals to cert x, and differentiate it, you will get dx is equals to 2 cert x du. Now we can see here 2 cert x du, cert x is equals to u, so we will substitute cert u into this cert x here and put it back in the equation. You will get something like this, where sine cert x becomes sine u and dx becomes 2 cert x du, where you change it into 2u du. Now you will get this equation here. Why? Because we bring the 2 to the front, so it will be times by the cert 2, and we will get sine u times u. From here you can't direct integrate, so we are going to use integration by part, where we will use log. So right now we have a trigonometric and also a normal function. So from here, from log, we're going to take the u, that will become u. Actually this is also equals to this, since u is equals to cert x, but I will be leaving it in u so it will be easier to look at. So now we're moving here for the substitution. U is equals to u, so du is equals to dx, and then this integrate v dx will be integrate sine u dx, and you will get negative cos u. And this is the formula, where we will be substituting into our original equation. You will get, this is u, this is our v, minus integral of our v du. Now look at the equation and our equation. U is u, v is negative cos u, and minus integral of negative cos u du, which is v du. Now we've gotten that, we can finally integrate this section here, and you will get u negative cos u plus sine u. Okay, sorry everyone, you don't have to write the here, since we are integrating by part. So we're gonna finish this part first. Okay, so integrate cos u, you'll get sine u. Now only we can put in the pi square and 0. When you get this equation, what we're going to do next is, we know that u is equals to cert x, so we're going to substitute that in, and you will get 2 cert x times negative cos cert x plus sine cert x. Now you substitute the value of pi square and 0 into the equation, where this side you will get 0 when you press the calculator, and this side you will get 2 pi cert 2 unit square, where as the question it asks to prove 2 pi cert unit square. And now we've got the answer, so it's shown. For question 3, they ask us to differentiate ln x minus ln a plus cert a square minus x square, where a is more than 0. So now, first we're going to write back the equation, and then we're going to differentiate this. So differentiate ln x is 1 over x, and differentiate ln a plus cert a square minus x square is 1 over a plus cert a square minus x square times x over cert a square minus x square. Now first what we're going to do is we're going to simplify this part here, where we will get this one. And then we will rationalize the denominator, and you will get something like this. Next, we are going to 1 over x plus this one, the part where we have already rationalized. And you will get something like this. And this minus this, you will get 0. So the only one left up here is a over x cert a square minus x square. Okay, for the second part of the question, they are asking us to deduce this equation right here. So from what we can see here, it is similar to what we get at part 1, where we differentiate ln x minus ln a plus a square minus x square. Now we know if we integrate a differentiation function, we will get the original equation like this. But right now, our a from this part here is 5. Therefore, we will times the original function with 5, and when we bring it to the side, this original function will be 1 over 5 times the original function. Now we can substitute this part here into the deduced part, where we will have to calculate. So 5 over 3 integrate of 4 3 1 over x cert 25 minus x square is also equivalent to 1 over 5 times ln x minus ln 5 plus cert 25 minus x square. Now all that's left to do for us is we will have to substitute in 4 and 3 into the equation, and we will get 1 over 5 times negative ln 2 minus negative ln 3. And we can simplify this, since negative makes positive. So negative ln 2 plus ln 3, which we will get ln 3 over 2 times 1 over 5. Therefore, 5 integrate of 4 over 3, 1 over x 25 minus x square is also equals to 1 over 5 ln 3 over 2. So to find the intersection point, we need to make y1 equals to y2 and make it into a quadratic formula, and then find the x value, where x value will get x equals to 0, x equals to 3, and x equals negative 1. Now we will have to substitute this into the y equation, any of it, to find the intersection points. And we will get in the intersection points are 0, 0, 3, 0, and negative 1, 4. So we have to draw the graph, and you will get graph something like this, where here will be number 4, and here will be negative 1, here is 0, and this will be 3, 0. That's all from me. Thank you.
A. Estimate this by using the trapezoidal rule with 6 ordinates correct to 3 decimal places. So dia minta 6 ordinates. So daripada ordinates ni kita dapat cari n equal to ordinates minus 1. So 6 minus 1 equal to 5. And then kita cari dia punya hash. the formula h equal to b minus a over n. B is the upper limit and then a is the lower limit. So 1 minus negative 1 over 5. And then you will get 0.4. And then you will construct this table. So as we all know, b is the upper limit and then a is the lower limit. So this box is a. The second one, a plus h. This is h, value of h. And then the third one, a plus 2h. And then you will keep adding the value of h until you get 1, until you get value of b, which is the upper limit. Then you will substitute the value of x into this. Then after substitute, the first column and the last column will be the value of a and b. The rest will be written on this side. And then after that, you calculate the total of this and this. Total for A is 1 and total for B is 2. And then lastly, we will calculate the area, and the formula is h over 2 bracket A plus 2B. So substitute the value h 0.4 over 2 and then A plus 2B. And then calculate, you will get the answer 1. Since the question asks to 3 decimal places, so you will write your answer 1.000. Move to question B. Find integrate 1 over 1 plus e to the power of negative x dx. So we simplify first. E to the power of negative x will be 1 over e to the power of x equal to e power x over e power x plus 1 dx. Then we have to find u because we will use the substitution method. U is equal to ex plus 1. Differentiate du over dx and then you will get e power x equal to du over e power x. Now we will substitute e power x over u and then times dx, which is du over e power x. You can rid of e power x and then what left is 1 over u du. And then integrate ln u. And then you will substitute u, e power x plus 1, upper limit and then lower limit. And then upper limit minus lower limit. And then substitute. And then the final answer you will get 1. See, the question asks to find the percentage of error for answer in B and explain your answer. This is how we find the percentage of error. Modulus exact value minus approximate value modulus over 1 times 100%. And then you will get 0%. Why 0%? We have used a large enough n such that we have got the best approximation for the integral when using trapezoidal rule.